Hi guys, subscribe Education Hub channel and press bell icon to get next video notification.
Hello students, welcome back. Now this is our third lecture on space missions. Before starting this new lecture, let's revise what we discussed in earlier two lectures. In the first lecture, we discussed about space missions, their need, their purpose, their objectives, and with that artificial satellites, different types of artificial satellites, their functions, their types. In the second lecture, we discuss about the critical velocity is needed to be given to the artificial satellites so that the satellites can revolve in the circular orbit around the earth. With that, we have discussed depending upon the height of the satellite above the surface, we classified the orbits of the satellite in three types: high earth orbit, medium earth orbit and low earth orbit. Okay, now if you are not observed that videos, I will suggest you to first go through that first two lectures and then go for the third one, then you will better understood this. Okay, now what just now I have told you that if you depending upon the function, satellite are made to revolve around the earth in different orbits: high earth orbit, medium earth orbit, low earth orbit, and this is depending upon the height of the object, height of that particular satellite. And this is thus it's become necessary that to take the satellite at that particular height at first and then give it the tangential, that is critical velocity, so that it goes on revolving around the earth. Means first important task is what? The satellites is needed to take that particular height at first. And how it is done? Obviously some vehicle it is required to take that satellite at that particular height, and these vehicles we call them as what? Satellite launch vehicles. So what are the satellite launch vehicles? Satellite launch vehicles are used to place the satellite in the specific orbit. ज्या ऑर्बिटमध्ये आपल्याला न्यायचं आहे त्या ऑर्बिटमध्ये घेऊन जाण्यासाठी जे काही तुम्ही वापरतात व्हेकल, आपण त्याला रॉकेट म्हणतो, दे आर कॉल्ड ॲज सॅटेलाइट लॉन्च व्हेकल. Now how these satellite launch vehicles are work? These satellite launch vehicles are work on, look at here, they work on what? Newton's third law of motion. आठवते तुम्हाला what is Newton's third law of motion? Correct. To every action there is always equal and opposite reaction. This is the principle, working principle of the rocket. Okay, for this purpose the fuel is needed to the rocket and their specific fuel is used for the rocket. It is fuel, particularly liquid oxygen, liquid hydrogen, some solid fuels also used depending upon the rocket. The gas and this fuel is made to be burned in the rocket, and because of the combustion gas is produced. Because the combustion of the fuel, the gas is produced, and which expands due to high temperature inside that rocket launcher, and this gas is expelled forcefully with a huge force. It is expelled through the nozzles at the rear end of the launch vehicle. At the rear end of the launch vehicle, look at here, this is the launch vehicle I have shown you here in picture. At its rear end, this is the rear end of this launch vehicle, and these are having nozzles, and from this nozzle, out of this nozzle, this gas is released, and as this launch vehicle, as a reaction of this, thrust acts on the vehicle. Huge thrust force in the upward direction acts on the vehicle, and which drives that vehicle high in the space with high velocity. This is the. Now depending upon the need, look at here, the fuel is how much height is needed, the is take how much, at how much height the object is to be taken, according to that fuel you will require. Look at here, so the structure and fuel, look at the structure of the vehicle and fuel used in the launch vehicle depends upon the weight of the, it depends upon the weight of the satellite and type of the orbit. Just now I had told that how much, at how much height you have to take that, it depends upon what, it height, and it depend upon the weight of the satellite, and that will decide the structure of the vehicle and fuel used in it. Now obviously this distance is not short distance, there is the distance is about thousands kilometers, some thousands kilometer, and obviously the fuel will be form major portion of the total weight of the launch vehicle. So as the fuel forms total weight of the launch vehicle, so launch vehicle is definitely is of huge mass or huge weight. In our textbook weight is used, okay. So this launch vehicle is to carry large mass of fuel with it, because this distance is not short distance. Even if we are to go at 200 300 kilometer per hour by means of our vehicle, we made the tank full with the fuel. So this is some 1000 kilometer, and so weight of the tank vehicle is increases. Now now look at here, if the vehicle will have more the weight, it will become difficult to launch it. And so to overcome this problem, look at here, to overcome this problem, launch vehicles more than one stages are used, in which the weight of vehicle is reduced step by step. If we will to take one only, means of one only stage launch vehicle, it has to take that entire vehicle will be go upward, and definitely you will require more energy to take that vehicle to that particular height. And so to overcome this problem, what we do, launch vehicles of more than one stage are used. What is done, in this weight of the launch vehicle is reduced step by step. How it is reduced? Look at here. For example, in a launch vehicle with two stages, okay, we are discussing here launch vehicle of two stages. After launching, fuel and engine in the first stage are used, okay, and this imparts specific velocity to the vehicle and takes to a certain height. Now what is did here? At first, look at here, when the launch vehicle with two stages were done, at first the fuel and engine in the first stage are being used, okay, and this impart gives specific velocity to the vehicle and takes to the particular height. Now once the fuel in the first stage is exhausted, finish, what will happen? It will trigger the fuel in the second stage. So the fuel in the second stage will be ignited, and what will it, and obviously the fuel tank of first stage will become empty. So the empty fuel tank and engine will get detached from the vehicle and fall either in sea or an unpopulated land, means no man land. Look at it, it is shown in here in the first stage. Look at it, this is the first stage is detached from the rocket, then this is second stage, and then this is the payload, or that is satellite in that particular launch vehicle. This is happen there. What will be the benefit of this? As the lower portion of the satellite launch vehicle has been detached from the launch vehicle, two benefits will get. Number one, now the vehicle will contain only one stage, so its weight will be reduced, its mass will be reduced, and again it is more height, so it can move even with higher speed and can attain a desired height. That's why the vehicles of more stages are being used. Okay, look at here in the picture here where shown here satellite launch vehicle of 4 stages PSLV made by our ISRO, and it has 4 stages. Booster rockets are there at the end. First stage solid fuel, look at your first stage using solid fuels, then second stage using liquid fuel, third stage again using solid fuels, fourth stage using liquid fuels, and that only shown here in interior diagram. This is the 4 stage rocket. But what are the limitations of this satellite launch vehicle, this rocket? The problem is that, or the limitation is that, they can be used only once. Once finished, they will be destroyed, and you have to build up the new one, and they are very much costly. They are too costly. It is means they are in crores of years. And so to solve this problem, what can done? So then spacecraft is a solution on this. Spacecraft is that launch vehicle which can use again and again, which can be used to put up the satellite or space or astronauts or what, they are in this particular orbit and they are returning back. This is done. Spaceships are, look at here in picture 1 spacecraft is shown to you. Look at here, stages also given what there. This is the look space shuttle. Then at the both side here, these are the booster rockets. These are the booster rockets. This is called as the main spaceship is called orbital. This is orbital. This is booster rocket, and this is the main fuel tank. This is the main fuel tank. This is the main fuel tank. Now when launched within 2 or 3 minutes, these booster rockets fall in the mostly in ocean. That's why launch stations are nearby the seashore. They are at seashore only, so they can be reused. These booster rockets can be reused, and then this fuel tank is fall. This fuel tank, when it attain the particular height, this fuel tank is fall, and then this orbital moves in the orbit, particularly in low Earth orbit, in this way, and then it can return back. It can return back to the Earth's surface after finishing the task. This is the spacecraft is used. Okay, in this way spacecrafts can be used to avoid the loss or to reuse the vehicle once again and again. Now in the first only lecture we have discussed that the space missions are carried out for launching the different satellites, and second to expand the horizon of knowledge, to know our universe, to know our solar system, and this is done in this way, space missions away from the Earth. Now space missions are not only carried out for setting the satellite in a particular orbit, they are also carried out to gain more knowledge about the universe, means how our solar system is formed. We know that now we are living in the galaxy called as Milky Way, so we want to explore if there are different solar system of the stars in our galaxy, because we are deeply curious about the universe, and our one task is that only, if there are someone like us, means a living organism in the universe, or we are alone in the universe, that is our task. And for this different purpose we are carrying out the space mission that are away from us. In this space mission, what we are doing in these space missions, spacecrafts are sent to the nearby objects in the solar system to observe them closely. Then different planets are there, out of the planets are there like this for different purposes. We are sending the spacecraft to the nearby objects, and then that's why we are having the information about Jupiter, Saturn. They are having that much moon. This is because of the space missions away from the Earth. And so what's the benefit of this? Obviously we get new information. We get new information from this such space mission and helps to understand the creation and evolution of our solar system. मग बिग बँग थेरी वगैरे जे आपण शोधून काढली किंवा काय शोधलं आपण, कशी युनिवर्स तयार झाली, कशी पृथ्वी तयार झाली, धिस इज बिकॉज ऑफ एक्सप्लोरिंग द स्पेस. हे सगळं केल्यानंतर ते आपण काढले. ते का ऑल ॲट अ सडन आपल्याला 2-4 दिवसात कळलेल्या अशातला भाग नाही आहे. आपण वेगवेगळ्या प्रकारचे रिसर्च केले, स्पेस रिसर्च केले, अँड सो दिस वी सक्सीड इन दॅट. ओके, फॉर सच मिशन्स. मग आता बघा वेगवेगळ्या प्रकारचे स्पेस दाखवले इथे मुद्दाम तुम्हाला. काय काय स्पेस मिशन्स केले इन दस अवे फ्रॉम द अर्थ. नासाने हे पर्टिक्युलरली केले आहेत बघा. व्होयाजर 1, 2, पायोनियर 10, 11 हे वेगवेगळ्या प्रकारचे सॅटेलाइट प्रोब्स आपण पाठवले आहेत. पायोनियर 10 हा जो आहे, लुक ॲट दिस पायोनियर 10. दिस is sent to the space on March 2, 1972. This is Pioneer 10. Pioneer 11 is on April 6, 1973. April 6, 1973. Then Voyager 1, look at here, this is the most famous one. It is launched on September 5th on 1977. This is Voyager 2, look at here, Voyager 2, August 20, 1977. This different. आणि त्याच्यातलं Voyager 1 तर आता 20 मार्च 2020 साली, 20 का 21 मार्चला तो पृथ्वीपासनं 22 बिलियन किलोमीटर अवे फ्रॉम होता. म्हणजे तो आउटर स्पेसमध्ये ॲक्च्युली आता गेलेला आहे. दिस इज द स्पेस मिशन अवे फ्रॉम द अर्थ. ऑब्वियसली फॉर दिस पर्पज द स्पेसक्राफ्ट मस्ट बी एस्केप अर्थ ग्रॅव्हिटेशनल फोर्स. म्हणजे त्यांची जी व्हेलॉसिटी विथ दे शुड बी लॉन्च, that is important here, and this we are discussed in the first chapter. So I request to go through the video of chapter 1, lecture of chapter 1, in which we are discuss the escape velocity. I think it will be 5th lecture, and in which you can have that formula, escape velocity. Look at it, V escape. We derive the formula that V escape is equal to under root twice gm upon r, or second formula what, V escape is equal to under root twice gr, where g is universal constant, is value 6.67 into 10 raised to minus 11 Newton meter square per kg square. Okay, m is the mass of the earth. It is 6 into 10 raised to 24 kg. Okay, r is the radius of the earth and it is meter. It is 6.4 into 10 raised to 6 meter. And if you use the second formula, then g will take what, approximately value, average value I am giving 9.8 meter per second square. Now if you use this formula, then we will get V escape is equal to under root, we have to put this value 2 into 6.67 into 10 raised to minus 11 into 6 into 10 raised to 24 upon 6.4 into 10 raised to 6, and on solving this we'll get answer is what, 11.18 kilometer per second. This is 11.18 kilometer per second. Means what just have to let the spacecraft should have velocity greater than escape velocity. Means velocity of the spacecraft, velocity of space is greater than what this v escape, and so it should be approximately or at least 11.220 kilometer per second. The velocity of the spacecraft should be this much so that it can go in the outer space. Okay, one interesting thing they are given, the most close heavenly body to us is definitely our moon, and the distance of the moon, average distance of the moon from the earth was 3,84,400 kilometer. Means light is taking more than 1 second to reach to earth from the moon, because speed of light, you know, that 3 lakh kilometer per second in the space vacuum, and it is taking more than that, will take 1 second. Means if you travel with the speed of light, it is not possible obviously. If you travel with the speed of light, then how much time it will take us to reach on the moon? Just within 1 second. We will land on the moon within 1 second. But when, if we travel with the speed of light, it is not possible, and the spacecraft, our spacecrafts are traveling with much low speed than that. Their speed is huge, no doubt, but they are traveling with low speed with that. The shortest, look at here, the shortest time taken by the spacecraft to reach the moon is only how much time? 8 hours. 8 hours and 36 minutes. So just calculate. I am giving you one question. How much this, what will be the speed of, or what was the speed of this spacecraft? ज्या स्पेसक्राफ्टने इतका वेळ घेतला 8 तास 36 मिनिटं, त्याने अंतर किती कापलं आहे? यू कॅन टेक दिस ओनली 3,84,400 kilometer. So what will the speed of that spacecraft? Calculate it and give me the answer. Okay, here we stops, then we'll meet in the next lecture. Till then, take care, bye bye, see you.